Solve it this one quickly. Again same formula. Lambda equals to h by mv. So v equals to, can I write h by m into lambda? H value is 6.6 into 10 to the minus 34. M value is 1.6 into 10 to the minus 27. 4 Armstrong. 4 into 10 to the power minus 10. Solve it quickly. What will be the value? Done. Done. Look, 1.6, 6.6, 4, 4. So 10 to the minus 34 plus 27 plus 10. So 10 to the 3 meter per second. Okay. Any doubt
Yes,
regarding this part?
no, sir.
Okay, then I'll give you another questions, and these two questions is IIT questions. Question number 6 and question number 7. The atomic mass. In this case, I'm telling you, in this case, just remember one formula: kinetic energy proportional to temperature. That formula we can derive as a chapter gaseous state. Okay, just remember kinetic energy proportional to temperature. So kinetic energy formula we can write lambda equals to h by root over of 2 me. This E is basically kinetic energy. So this kinetic energy we can changes to temperature. This T is nothing but temperature. Okay, this formula is required. Okay, just write down the atomic mass of atomic masses of helium and neon are 4 and 20 AMU respectively. Okay, what is the ratio of de Broglie wavelength? Wavelength of helium gas at 73 degrees centigrade compared to neon gas. Neon gas at 727 degrees centigrade. Okay, solve it. Option A 4, option B 25, option C 16, option D 5. Remember, in this case temperature should be in Kelvin, not centigrade. If the centigrade is given, you have to convert to Kelvin. Suppose minus 27 degrees centigrade means how much Kelvin? Minus 27, minus 73, sorry, minus 73 plus 273. 273. That means 200 Kelvin. Okay. And 727 degrees centigrade, which means 1000 Kelvin. 727 plus 273. which means 1000 Kelvin. Okay, this one is required. Just solve it quickly. I'll give you 5 minutes for that.
Sir, is it 5D? 5.
Very good. Very good. Option D. Okay. So just write down how can you solve lambda helium by lambda neon. We
And
can
as the
write
H is the same, I took out the H, sir. So then I just did the root over
yes,
2m
yes,
times
yes.
temperature
Just very good, very good,
by
very good.
2%.
So correct. Just this one. Lambda mass of neon into kinetic energy of neon by mass of helium into kinetic energy of helium. Look, this lambda is fixed for all. Lambda and this H and T fixed for all. Just cut all the stuff. Just put the value. What is the mass of neon? Mass of neon is 20. Kinetic energy, can I write temperature? Temperature of neon. This one is 4. Temperature of hydrogen. So this one 20,000 into 1000 divided by 4 into 200. So this becomes 5. This becomes 5. This one is 5. Okay. Any doubt? Any doubt regarding this part? Okay, then I will give you one questions which you have to solve in your homework. Okay, question number as homework.
Okay,
Okay,
sir.
question number 7. This is also IIT level question. Just write it down. Okay, an electron, a proton, and an alpha particle have kinetic energy of 16 E, 4 E, and E respectively. What is the qualitative order? Qualitative order of their de Broglie wavelength. Okay. Option A, lambda p. Lambda p means wavelength of proton greater than lambda alpha wavelength of alpha particle greater than lambda e wavelength of electron. Next, lambda e greater than lambda p greater than lambda alpha. Option C, lambda alpha greater than lambda p greater than lambda e, and option D, all are same. Okay, this is a SW. Try to solve it. Okay, remember, in this case only kinetic energy is
Okay,
given,
sir.
but in this formula mass is also very important role. Mass value is not given here. In your first 2-3 class I am already talking about the what is the mass of electron, what is the mass of proton, what is the mass of alpha particle. That all the stuff I already completed. Okay, just try to solve it. Okay, as a SW. Okay, then that's end for this de Broglie equation. Next class I will start the Heisenberg uncertainty principle and the quantum theory, all the Heisenberg uncertainty principle, after that Bohr's orbit and all the stuff. Okay, okay, bye, take care,
Thank you, sir.
thank you.